found it was 62.5. I think I need to, anyway, so let me see if we can do it here with you guys. So we have, so the processor is, it's an 8-bit processor. So that means in 1 second, it will perform 8 bits times 16 million. So in 1 second, it will perform, so this should be 128. Or bits, okay? So it will perform 128,000 bits in 1 second. So the question is, what about 8 kilobytes? So 8 kilobytes, so that is 8 times 1,000. Then a byte has how many bits? Should be 1 byte is equivalent to 8 bits. So that should give us 16,000. So if it takes 1 second to execute 128 million bits, how long will it take to execute 16,000 bits? Okay. Okay, see, Isaac has already calculated.
No, it's actually just a correction. It's supposed to be 64,000 bits instead of 16,000 bits because 8 times 8 is 64.
Oh, yeah, you're right. Yeah, you're right. Yeah, so this should be 64. Correct. Okay, clear. 4,000. So you divide. Okay. So what do you get? Let me see. Divide by 28. So I have 0.0005. Yes. So if you multiply this by 1,000, you have 0.5 seconds. 0.5 milliseconds. Okay. So it will take. So actually, so this is equivalent to 0.5 milliseconds. So I made a mistake in my calculation. So in my calculation, I forgot to add, I forgot that 1 byte is equivalent to 8 bits. So anyway, I hope you guys have gotten the whole idea. Okay, so I think we can start. Any question before I start, or anything that's not clear? Okay, so today we are going to cover 2 things, yeah. So the Arduino microcontroller and the Node-RED microcontroller. So these are tools. So today's class is basically, I'm just going to take you through tools that you can use to design an IoT application or an embedded system application. So there are many microcontrollers. I chose Arduino because for beginners, it's the easiest to work with. So Arduino is the easiest to work with. So that's why I chose Arduino. So Calvin Ngumo is asking if a microcontroller can multitask. I remember I asked you that question and you never answered, so I'm not gonna answer it either. Anyway, so I chose Arduino because, yeah, as I said, it's the easiest for beginners to learn. So I don't know if maybe most of you in this class like to do work with sensors and microcontrollers. So maybe they've already familiarized themselves with Arduino. But for it's easy to work with. Everything is almost straightforward. But as we progress with the course, I think we'll work with more microcontrollers. So for today, I just want to introduce the Arduino. Then we'll get to Node-RED. So Node-RED is basically for helping you virtually design your system and actually test, simulate it. So when we get there, we'll see. So an Arduino is basically a programmable hardware. So it's a microcontroller. And then it has a special bootloader. So you'll hear of something known as a sketch. So a sketch is sort of like an IDE. So it allows you to write your program and then you upload it. So that is what is known as a bootloader. Once you've written your program, you upload it to the Arduino microcontroller you're working with, and then it will execute that code. Okay, so the code is usually in C. So start familiarizing yourself with the writing C programs if you want to work with Arduino. And then, so we'll go to the website. So for now, I just want to explain a few things. So you'll hear of a board. So a board is basically a microcontroller. So remember, a microcontroller had the 5 things. So it has a CPU, input, output, it has RAM, ROM. Okay, so a board like an Arduino will have all those 5 components. Then you have a shield. So in the website, you'll see a board, you'll see a shield. So a shield is something that adds more capability to a board. So a board, for example, just has the processing ability. Maybe you want that board to connect to a Wi-Fi, then you need to add a Wi-Fi shield. You want it to connect to a GSM, maybe you want to send text messages, you buy a GSM shield, and then you plug it on top. So that is how it works. Yeah? Then Sketch, as I've mentioned, this is a program. So this is where you'll be writing your program. How you want your board to behave, what you want it to achieve, what you want it to perform. You'll write it inside the Sketch, and then you upload to the board, not the shield, the board. Yeah, then it will execute it. Then you have sensors. So there are many sensors. I'll go over the website, you'll see it. Then for sensors, there are 2 types of sensors. There are digital sensors and there are analog sensors. So you need to differentiate the 2. I think we'll have a class where we'll go through sensors. But for now, just know that the Arduino, for the input and output, it will allow you to have a digital input and an analog input. So depending on the type of sensor you're dealing with, if it's digital, you have to know before you actually connect it. So there are many Arduino flavors. So these are just microcontrollers. Yeah. So Uno is the most basic and the most popular because it's cheaper, but it's less powerful. Yeah. Then there's Leonardo, Lilipad. Lilipad is the smallest, so you can even it's usually even used for in the textile industry. So, for example, you want to, because it's very light, you can even attach it to a cloth, and then you can sense things from the cloth and do whatever you want to do with that data. So these are just examples of Arduino boards. So depending on the application, you pick one. So we'll look at a few, look at the specs. Then these are the add-ons, the shields. Okay, so you can add the touch screen, servo motor, Ethernet, audio. Okay, So these are just shares. So depending on the application you want to achieve, you buy the shield that you want. So if you want maybe to connect to a GSM network, you buy a GSM shield, okay? And then you plug it on top of your board. Okay? So this is how the board looks like. So this USB plug is where after you've written your sketch, you'll use this to upload. You'll upload your deemed general purpose. So no, the general purpose. Okay. The reason is because when you have no, Arduino is not a spy. You see that you're writing like a program that will perform a specific function. So Arduino does not have an operating system. So there is no way it can be a general purpose microcontroller. But maybe as they progress the technology, maybe they'll get to that stage where it has an OS. The other microcontrollers, for example, like Raspberry Pi, that is a general purpose microcontroller because it comes with a lightweight Linux operating system. So whatever you can do on your Linux computer, you can do on that controller. So that is a general purpose microcontroller. But for Arduino, as far as I know, it's not a general purpose microcontroller. So I hope I've answered your question, Stephen. Okay, so then you have the analog pins here, then you have the digital, okay, then you have the serial out, then this is the reset button. So uploaded your program. If you want it to restart, you click on this button, okay. Then you have the power. So you have two sources of power. So these ones are output. Okay. So if you want the Arduino to be a source of power to make a component, you have a 3.3 power source or a 5 volts power. And this is how you power the Arduino. Then this is the microcontroller it's using, okay, at Mega 328. Okay. So you realize that most microcontrollers have all these. The only difference will be the microcontroller. So this microcontroller, as you can see, these are pins on the sides. So if you are able to, once you get a physical Arduino, if you're able to turn it around, you'll see that all these pins here are just extensions of these pins here. Okay. So this is the one that has all this small chip here has a CPU, it has input, output, and everything. Okay. So it's just connected all these. So it's connected to this, it's connected to this. So this board just connects these to all these, okay? So that you have a bigger interface to work with, okay? So the most important thing here is this at Mega. This is the microcontroller itself. This is just extensions to help you have a better interface. Steven is asking a question I don't understand due to the various shield extension that it supports. Oh, no. So it's not here. I think I've gotten the question. So these are the features. We look at them. So this is a capabilities. So for the each bit. So as you can see, it's a RISC architecture. So I hope you remember the difference between RISC and CISC. Okay. Then you need to pay close attention to the voltage. So if it's 5 volts, please, when you're doing your components, make sure you don't do under voltage or circuit. 6 analog pins. Then these are the output. Okay. Then this is the flash memory, 32 KB. Okay. So I think this is where you'll be, when you load your program, it will be stored here. Then look at the clock speed, 16 megahertz, okay? 16 megahertz. So we have a question here. microcontrollers can multitask through concurrency and redundancy. But Daniel Gitao telling you guys, oh, it's me. Anyway, we'll look at that later. So it has 16 megahertz, okay? So for example, so let's go to the website. So if you go to the website, there are two places I want you guys to maybe try. So first of all, the products. So these are the shields that are available. So Uno is here. So anytime you want to buy something, for example, if it's Uno, always go to the technical. This is the flash memory, and you can see it's 16 megahertz. So this is this microcontroller is, okay. If you go to another, maybe this one, Leonardo. So this is processor, okay. Clock speed. I want to look for another one that's more powerful, maybe. Powerful. Let me look at these. So you can look at this. This one has a 32 megahertz clock speed. So you can see the flash memory is 196. So it's this microcontroller is Intel. It's very powerful. So depending on is very so always go to so that you know I need this amount and I want. So if you want a nano, it's smaller. So this one is smaller, as you can see, but which is the power. So always when you're doing your design, make sure you understand what you're working with. Okay. So this one is very powerful and small. So 20 megahertz, and it's small. Okay. So that's types. These are the shields. Okay. So you want your Arduino to connect maybe to something else. You add a shield on top. So these ones are usually plugged on top of the Arduino. Okay. So for example, a motor shield you have here, proto shield. Okay. Wi-Fi and everything. So these ones, initially, these ones were called modules, so the IoT things. So this one already, so for example, instead of buying two things, so here, for example, let's say you want, this is a memory shield. So you want to add more memory. You have your board, and then you want it to have more memory. Okay. For example, you want to add 2 MB to it. You'll have to buy two things. Okay. The board and then this shield, and then you plug it on top of your Arduino. So instead of doing that, you can buy these IoT, or is it IoT, Internet of Things. So these ones, previously, back in the days, it was called modules. So it allows it is one component that has two capabilities. For example, this one. So it has for example, a board and a Wi-Fi capability. Okay. So one board, it can even connect. So if you don't want to buy two things, then you can buy one, and then you're able to actually just do two things at the same time. Okay. So you can see now it has more space, power, frequency. So these ones were not in the Uno. So this is, so you see what you can work with. And this is the clock speed. Okay. So still depend on the application. Then if you just want to do, so this is for education, you just want to learn, you can buy a starter kit. So usually what start mode does is it buys this starter kit. So this is Classroom. So it comes with an Arduino board, a few sensors. So it just comes with a number of components. So it allows you to work around it, try new things. So it has sensors. It's just a starter kit. So it helps you to just, if you have no specific idea or a specific design in mind, you can just buy these kits. Okay. Then these ones are products. So Lilipad, you can see very small, a very small microcontroller, but it has, so if you look at the specs, so flash memory, it's an 8, so it's small, but also it compromises on the clock speed, so it's not as powerful. Yeah, so you use it to maybe perform lighter tasks. Okay. Then there's also something else I want you guys to look at. These products, resources. Let me see. Education. Actual platform. That's what I'm trying. They've launched a virtual platform. Yeah, this one. So it allows you to basically try to create your application virtually and test it, I think, before you do anything. So maybe you can try to, this Arduino web editor, you can try to sign up and just play around with it. Okay. So just sign up and just play around with it, see what you can do, learn a few things. Because what I want you guys to understand is for now, I want you guys to familiarize yourself with these components. Try to do basic things, just a microcontroller that can connect to a sensor, and then maybe an output and something. So that by the end of the class, I want you guys to be able to design an IoT application or an embedded system application that can analyze something or run a pattern from a sensor data, or can extract patterns. Okay, so maybe it can realize that this data is coming. It has sensor data that's coming maybe after every 1 second, and then from that it can learn that maybe something happens every day at 9 a.m. Something like that. So by the end of the class, I want you guys to design high-end applications. So for now, that's why I'm trying to introduce these things so that you can try familiarizing so you understand. So you never have to how it works. Uh, is sign up, try to do something about and learn as possible. Then the next part is the Node-RED. Okay, so one, this is a web. It's a designing tool. It's a software that you use to design IoT applications. Okay, so it's an editor. So it uses the drag and drop. So you want a component, you drag it and drop. Okay, so for example, this is it. Let me see if I can share a video so at least to get let me see if I can share a video of this.
Hi, my name's Nick O'Leary and I work for IBM's Emerging Technologies Group.
Can
I want to give you a
hear?
quick introduction to a tool we've created called Node-RED. Node-RED is a visual tool for wiring together the Internet of Things. Data from many different sources, whether it's physical events in the real world, whether it's digital events, social events, whatever it may be, and having tools that let you really quickly combine those streams in different ways to explore what you can do with it is a really powerful tool to have. When you start Node-RED, you get this view in your web browser. With its palette of nodes down the left side, you can quickly start dragging nodes on, wiring them together, and hitting deploy to create your application. Here is a very simple application with an inject node and a debug node that whenever I hit the inject, a message appears in the debug pane. And it's these building blocks you can start creating your own applications from. Here I've got a node that knows how to talk to the Twitter API. It walks me through authenticating the node against my account. And I'm going to tell the node to look for any tweets mentioning the hashtag #FridayFeeling. But because I want to do something with those tweets, I can drag in a node for a Mongo database instance, and I just wire the Twitter node into the Mongo node. I configure the Mongo node to connect to a local database. For IBM's Emerging Technologies group. Now I want to give you a quick introduction to a tool we've created called Node-RED. Node-RED is a visual tool for wiring together the Internet of Things. We recognize the fact that IoT solutions combine streams of data from many different sources, whether it's physical events in the real world, whether it's digital events, social events, whatever it may be. And having tools that let you really quickly combine those streams in different ways to explore what you can do with them is a really powerful tool to have. When you start Node-RED, you get this view in your web browser. With its palette of nodes down the left-hand side, you can quickly start dragging nodes on, wiring them together, and hitting deploy to create your application. Here is a very simple application with an inject node and a debug